Hey everybody, welcome back. This video is looking at dividing using standard form. So multiplying is the previous video, it's part of a playlist. So if you don't know how to multiply, watch that video first. We're going to be looking at how to divide using laws of indices. Okay, so before we do this, there's a skill that you need to master, which is using the laws of indices with division. So I will do the first example for you, and the law we're going to be using is a to the power x divided by a to the power y is equal to a to the power x minus y. So when the base matches, in this case the base is a, if you are dividing the powers, if you're dividing these terms, then you subtract the exponents. So I'll do the first example for you here. So first example is we got a division here, so we're going to write this as a fraction. So this is the same as 16 a to the power 10 over 4 a to the power 4. So first focus on the numbers. So 16 over 4 is just going to equal 16 divided by 4 is 4. Then you want to focus on these terms here. Now, what I've just circled in blue is actually just the same thing as this, is a to the power 10 divided by a to the power 4. So we're using this rule here, and that means we're going to do 10 take away 4. So this is going to be 10 take away 4 is 6. So the second bit is a to the power 6. This is your answer. That's your final answer as well. So 4a to the power 6. Now I'm just going to tidy this up so it's a bit easier to visualize what's happening. So this is going to be equal to 16a to the 10 over 4a to the 4. 16 over 4 is 4. a to the power 10 divided by a to the power 4 is a to the power 6. Okay, so using that rule, can you answer question 2, 3, 4 and 5. Have a go, pause the video, and then I'm going to show you the answers in 3, 2, 1. Okay, here we go. First thing we want to do here is write this as a fraction. So this is going to be 8a to the power 5 over 2a cubed. Focus on the numbers first. So 8 divided by 2 is 4, and then a to the power 5 divided by a to the power 3 is a to the power 5 take away 3, which is 2. So I hope you got that one right. Okay, next one. We are going to be doing this as a fraction, so 10x to the power 6 divided by 4x to the power 2. So just on the side, 10 over 4, when you simplify that fraction, it becomes 5 over 2. So we know that this is equal to 5 over 2. And then we've got x to the power 6 divided by x to the power 2. So x to the power 6 divided by x to the power 2 is equal to x to the power 6 minus 2, which is x to the power 4. Now, this has to go on top because it's a positive 4. If it was negative 4, where we will get to those questions later on, but for now we're going to leave it like this. Another way to write this is 5 over 2 and x to the power 4. You can write it on the side, so it's just a fraction. The fraction is just like writing 4a squared, right? So you've got a coefficient in front. The number in front is 5 over 2, and then times x to the power 4. Okay, the next question, we've got, write this as a fraction. So this is going to be 8 times 10 to the power 4 over 2 times 10 cubed. So deal with the numbers first. So 8 over 2 is 4. Times, and then you deal with the powers of 10. So 10 to the power 4 divided by 10 to the power 3 is 10 to the power 4 minus 3, which is 1. And that's your answer. Happens to be in standard form here. And in the last example, we're going to do write this as a fraction. So 5 times 10 to the power 4 over 2 times 10 to the power 3. So 5 over 2 just stays as 5 over 2 since it doesn't simplify. So 5 over 2 multiplied by, and then we're going to simplify this. So that's going to be 10 to the power 4 minus 3 is 1. So 5 over 2 times 10 to the power 1. That's your answer there. Okay, so throughout this exercise, what you've actually ended up doing is you figured out the way to divide when we're dividing standard form, because actually this is standard form division here. We're going to do some practice questions here just to show you the formal layout for these types of questions, and these are slightly different to the examples you just did. So if you're asked to divide with standard form, we cannot use commutativity because division is not commutative, so we can't just swap the numbers around. What we want to do is write them as a fraction, and that's what we're going to do here. So this will become 2 times 10 to the power 9 over 2 times 10 to the power 4. Now we can actually split this up. We can just write this as 2, so that should say 2, sorry, that should say 4. So this is going to be 2 over 4 times 10 to the power 9 over 10 to the power 4. We can split this up because everything's being multiplied on the top, everything's being multiplied on the bottom, the numerator and denominator. And then we can simplify this. 2 over 4 is a half, so let's write this as 0.5. You could leave it as 1 over 2 as well, times 10 to the power 9 minus 4 is 5. So that's your answer, 0.5 times 10 to the power 5. This isn't your final answer though, because it wants you to work this out in standard form. So you may have spotted that this number here is not between 1 and 10, so we're going to need to fix that. So we're going to change this number here into 5 times 10 to the power negative 1, and then we're going to bring this number down, times 10 to the power 5. So just to be clear, we have this number here is the same as this number here, and you are multiplying by this number here, which is the same as this number here. So both of these expressions are the same. What we want to do now is, if you think back to the multiplication example, we want this to be 5 times 10 to the power, and we're going to add these. Negative 1 plus 5 is 4. That's your answer. Okay, next example. We're going to write this as a fraction first. So 8 times 10 to the power 7 over 2 times 10 to the power 5. Now we're going to split this into two fractions, two separate fractions. So this is going to be equal to 8 over 2 times 10 to the power 7 over 10 to the power 5. 8 over 2 is 4, and 10 to the power 7 divided by 10 to the power 5 is 10 to the power 7 minus 5, which is 2. Now this is convenient because it's already in standard form. However, sometimes you may end up with something like that which is not in standard form, so you would have to convert that yourself. Do not forget to convert that at the end of your answer. If you get an answer like this, students often forget to convert this into that, so it has to be in standard form. Okay, we're now going to look at one of the hardest examples, is what happens when you have a decimal here. Now, if you don't have a calculator, this is actually, they will give you nice numbers. They're not going to give you crazy numbers to divide. So you may notice 2.4 and 3.2. There's something we're going to be able to do with this. So first of all, the method is the same. You just want to write this as a fraction. So this is equal to 2.4 times 10 to the power 6 over 3.2 times 10 to the power 4. Now what you want to do is split this up into two different fractions. So it's 2.4 over 3.2 times 10 to the power 6 over 10 to the power 4. What you'll find is this side is really straightforward, because 10 to the power 6 divided by 10 to the power 4 is just 10 to the power 2, because you do 6 take away 4. So we can rewrite that straight away. What you need to focus on here is what to do with this part. Now on the side, I'm going to show you how we can deal with this. 2.4 divided by 3.2. If you remember with fractions, if I have a fraction like 2 over 5, I can multiply it by, if I multiply the numerator and denominator by any number, as long as it's the same number, for example, times 10 times 10, I end up with 20 over 50. And the big idea here is 20 over 50 is the same as 2 over 5. They are equivalent fractions. So we're going to turn this into an equivalent fraction, and we're going to swap it with a nicer one. So let's multiply this by, let's multiply this fraction here, 2.4 over 3.2, by 10 over 10. So this is now going to equal 24 over 32. It's a bit nicer because we don't have any decimals, but you must remember that 2.4 divided by 3.2 is equivalent to 24 over 32. So let's write that here, 24 over 32. And then we've written this question out in a nicer way, and we now need to work out 24 divided by 32. So what goes into 24 and 32? Now you can do this the long way. You can keep dividing both sides by 2 and then divide by 2 again, divide by 2 again, or you may have spotted that 8 is the highest common factor. So if you divide by 8, you get 3, divide by 8, you get 4. So this is now equal to 3 over 4 times 10 squared. And now we can turn this into a decimal, which is 0.75 times 10 squared. Okay, so if we bring this up here, 0.75 times 10 squared. There's one problem with this, and that is the fact that this number isn't between 1 and 10. So to make it between 1 and 10, the decimal has to go there. So we're going to change this into 7.5 times 10 to the power, well, we need to move it back 1 to keep it equivalent. So this 10 to the power negative 1. And then we're going to bring the times 10 squared down. So I'll keep that in the same color. So times 10 squared. Okay, the next step is simplify this. 7.5 times 10 to the power negative 1 plus 2 is positive 1, so 7.5 times 10 to the power 1. That is your final answer. Bit more work involved, but none of the individual steps were particularly scary. It's just you need to be aware of writing it as a fraction, splitting it into two parts. This bit is straightforward, you subtract the exponents. This bit here, turn it into a nicer fraction, an equivalent fraction, and then converting that back into a number between 1 and 10. So that is going to be how you do your division. Now here's some practice questions for you to try here. Pause the video and have a go with these, and then I will show you the answers in 3, 2, 1. Okay, so here are the answers for this. Check your work. I hope you did well. I hope that was useful. I will see you in the next video, which looks at adding and subtracting with standard form. So far we've done multiplying, this is dividing, we're going to look at adding and subtracting. Smash the like button.
Not this time. Not this time. Wrong. Not this time. Not this time. You're wrong. Not this time.